Hi friends, this is Gautam. In this video tutorial, I am going to discuss about fast switching. So in last video session, we have discussed about process switching. So this is the first time you are watching this video means please go to my YouTube channel and check the process switching concept. Then afterwards you can see this fast switching concept. So you can able to understand the concept and also you can able to understand the difference between process switching and fast switching. So in packet switching modes, there are three modes are there: process switching, fast switching and chef. So in this video session I am going to discuss about fast switching. Okay, so this is the diagram. In router we have two plans are there. One is control plan and another one is a data plan. So in control plan, the router using routing protocol to find out the shortest path from source to destination, that will be present in the control plan. So in data plan, so after finding that shortest path, how the data traffic will be flow from source to destination, how the traffic will be switching, that should be present in the data plan. Okay, so ingress interface. So ingress interface is incoming packets. So the first packet coming to the router. So the router CPU involved to find out the destination network. So it works like a process switching. So the first incoming and outgoing packet. So the first echo request and echo reply. So the two packets will be working like process switching and rest of the packets will be working like fast switching. So fast switching means the router will create the cache. So the first time the first packet from source to destination, if you are pinging means that information will be stored in the cache. So the next subsequent packet of for the same source and destination, so that packet will be switching through the caching. So the first packet will coming to the incoming packet to the router. So the router CPU involved and check its routing table, what is the next hop IP, what is the outbound interface of that router, and it will rewrite the layer 2 header, source MAC address as well as destination MAC address, and the packet will be sent through the outbound interface. And same like the return traffic also, the router will check the routing table and check the what is the next hop IP and what is the outbound interface and rewrite the layer 2 header, source MAC address and destination MAC address. The packet will be sent to the source. So that's why the first two packets, ICMP echo request and echo reply, these two packets will be working like process switching. Rest of the packet will be working like fast switching. So the first two packets, while they're working like process switching, the information will be stored in the fast cache. So here you can see the diagram, fast cache. So the subsequent packets in a data flow, the subsequent packet for the same source to destination, it won't involve the router CPU. It directly comes to the router, check the fast cache and switching that packet. So when compared to the process switching, in fast switching the CPU utilization is very less when compared to the process switching. Okay, we can see the example. Okay, this is my example scenario. Here I am using one router and two hosts. So host A2 router I am using 10.1.12.0/24 network, and host B2 router I am using 10.1.23.0/24 network. So host A I will assign 10.1.12.1 IP and host B I will assign IP as 10.1.23.1. So router FA0/0 I will assign IP as 10.1.12.2 and router fast Ethernet 0/1 I will assign IP as 10.1.23.2. So what is the MAC address? Layer 2 MAC address of host A and router fast Ethernet 0/0 MAC address, and this is FA0/1 MAC address. This is host B MAC address. Okay, now I have to enable packet switching mode as a fast switching in router. So just go to the router interface FA0/0. You have to give IP space route-cache. Then interface FA0/1 you have to give IP space route hyphen cache. So after giving this command, the fast switching is enabled. So how you can verify the fast switching is enabled? So just go to the router, show space IP space interface space FA0 bar 0 pipe section IP space fast. Here we can see IP fast switching is enabled. So through this you can verify the fast switching is enabled or not. Okay, so in fast switching, the first packet from source to destination is working like process switching. That information should be stored in the cache table. So in the router, how we can check that cache table? So you have to give show space IP space cache. Here we can see this is the output for the cache table. So in red color box I mentioned 0 entry. So there is no entry right now. Okay. So that's why I'm getting 0 entries. Okay, so next I am doing the debug. So in last video session I have to give an debug IP packet detail. So when I'm pinging from source to destination, 5 packets are sent. So totally in debug output I will get 10 packets. So 5 packet is ICMP echo request and 5 packet is ICMP echo reply. So here same in router I given debug IP packet detail, and afterwards I am trying to ping from host A to host B. I will get only 2 packets in debug output because ICMP echo request and ICMP echo reply. So that information stored in the cache table. The next packet it will send through the cache. So here we can see the first packet. So the first packet working like a process switching. So the source IP is 10.1.12.1. So this IP is a host A IP and destination IP is 10.1.23.3 is a host B IP, that is destination IP. So in router the packet is receiving on fast Ethernet 0 bar 0 and routed via RIB. So routed via RIB means routing information base. So that is routing table. Through the routing table it will check the what is the next hop IP address, what is the outbound interface of the router, and what is the layer 2 header. Rewrite the source MAC address as well as destination MAC address. So here we can see source IP 10.1.12.1 and destination IP is 10.1.23.3 and outgoing interface is fast Ethernet 0 bar 1 and next hop should be on 10.1.23.3. So the packet will be forwarded. This is a ICMP echo request. ICMP type 8 means it should be an ICMP echo request. So the echo request is sent through process switching. So immediately that information should be cached. Here we can see created cache entry for 10.1.23.3. So this IP is a destination IP. So that information is stored in the cache table. Okay. Next one, return traffic. The ICMP echo request is sent. So the return traffic is ICMP echo reply. So source IP is host B IP 10.1.23.3. So it receiving on fast Ethernet 0 bar 1 or router. Destination IP is 10.1.12.1 and outbound interface is fast Ethernet 0 bar 0. The next hop should be on 10.1.12.1. So through the routing information base routing table it will be forwarded, it will be switching. So ICMP type 0. So again they created the cache for return traffic. So return traffic is 10.1.12.1, that is the IP for host A. So now host B and host A, so both entries are cached. So now we can check again in router. I'm giving show IP cache webros. So after giving this command, here we can see I got 2 entries, this source IP, host B IP and host A IP. So both of them are cached in the cache table. Okay, so 10.1.12.1, this IP if I want to reach means in that router outbound interface is fast Ethernet 0 bar 0 and next hop should be a 10.1.12.1 and this is the next hop MAC address and this is the source MAC address of the outbound interface fast Ethernet 0/0 MAC address, and last 4 digit is Ethernet type. If I want to reach 10.1.23.3 IP means in router, the outbound interface is fast Ethernet 0/1 and next hop should be a 10.1.23.3, and this should be a next hop MAC address, and next one should be a source physical interface MAC address. This is an Ethernet type. So the first packet only, it will be working like process switching. The next subsequent packet for same source to destination, it will be working through cache, fast cache. So the router CPU utilization is very less when compared to the process switching. Okay friends, I hope you understand this concept. So next video session we will discuss about the CHEF, last packet switching mode. Thank you friends, thank you for watching my video. So please subscribe my channel and share to your friends, as well as please press the like button. So if you have any queries, drop me email fgowthamraj1@gmail.com. Otherwise you can ping me in comment section. Thank you friends, thank you for watching my video.